So streaming Kafka at scale, streaming events in aviation. So um, one of the things about most businesses in 2023, 2024 is that they are indeed event-driven businesses. They react to things happening around them from their customers and their suppliers, be they, transactions or contracts or just events. And the extent to which they recognize that they're event driven rather than being driven by, collecting a bunch of data and then running reports and then retrospectively looking back at what happened and trying to figure out what to do next, the better they're able to operate in the world the way it is now. Now, aviation is an environment where it's much easier to understand and recognize that this is an event-driven business, because there's absolutely no doubt about it. Flights are landing, flights are taking off, people are checking in, people are buying tickets, clearances are given, and so on. So aviation is kind of the poster child for event streaming at scale. And the Flight State Engine project that we did at Virgin last year is a perfect example of Kafka at scale and a perfect example of streaming events in aviation. Okay, so the Flight State Engine project was, as I've mentioned before, it was a project to migrate this important tool for Virgin called the Flight State Engine off of its existing infrastructure onto Kafka. The Flight State Engine, what it does is it integrates flows of data coming in from multiple different sources. They're sources that aren't synchronized with each other. They're different vendors. They're different data feeds. It's everything from Air Services Australia to airports to catering companies to Sabre, which is one of the worldwide reservation systems. So they have all of these different flows of information coming into the into the company, and they need to reconcile that to get a consistent and holistic view of the state of a current flight and how that state is evolving as the aircraft is, scheduled and then has a departure time that's estimated, and as it gets closer to departure, then the estimates change, and then it's all of a sudden it's off the blocks and now it's in the air and so on. So the Flight State Engine takes all of these disparate, contradictory, out of sequence sources of information, converts them to a common language or a common schema, resequences them where necessary, and then publishes out the other side of it a consistent, correctly ordered series of events that reflect all of the states of all of the flights that Virgin manages. And then there's dozens of downstream systems and indeed external third-party vendors and so on that rely on that feed of data coming from FSE to help run their businesses or their operations. So so the FSE was built on old technology, and the purpose of the project, the objectives of the project, were to migrate it forward. The first point on writing a streaming application. So this is what a streaming application looks like. You've got lots of different data sources down the left. They are interfaced to with what are called Kafka connectors. That's what all these Cs are. And these are called source connectors because they subscribe to incoming events from all kinds of different systems. They can be, in this case, it was Oracle WebLogic JMS, but it can be IBM MQ, it can be S3, it can be Salesforce, it can be, there's hundreds and hundreds of these different connectors. And they convert the incoming messages to Kafka and publish them onto Kafka topics. And then in our case, for each of these incoming streams of information, we had a transformer that transformed these disparate sources of data into a common language, which is called Air Event. And then the Flight State Engine, or sometimes called FSE logic, state logic component, which is really the heart of the Flight State Engine, which is here, listens to this incoming stream of error events, resequences them where necessary, correlates them to make sure you're getting a consistent view of what's going on with the flight, and then publishes messages out to a new Kafka topic. And then there's some internals in here, like we have we use a stream of reference data. We converted a relational database into its own Kafka stream, which is a very common pattern. This is reference data about airports or something, and we were able to join this feed of reference data with the common language, the error events, in order to enrich these messages and get more information out of them. There is a part of the Kafka ecosystem is called KSQL, KSQL, also known as KSQL DB sometimes. And KSQL is a SQL-like language which you can use to write queries that look a lot like like SQL, that let you on the fly join different streams of data together, extract things extract elements from two or three or more streams and put them together, restructure them, filter them, transform them. And if you it's not essential, but it allows you to very quickly, it's a very expressive language for very quickly pulling together multiple streams of data and generating new streams out the other side, without having to do a lot of complicated programming. KSQL is a perfect example of where you're far better off working with Confluent than trying to go it alone. KSQL requires its own set of servers, a KSQL cluster, that cluster is related to the cluster of Kafka brokers that are the main Kafka infrastructure, and it needs its own TLC, its own fine tuning, its own management, its own maintenance. And trying to run your own KSQL servers is just is foolhardy. You're far better off getting Confluent to do it for you and just using it. And what that means is that what we were able to do with KSQL at Virgin is we were able to offload a lot of processing. So there was a lot of stream processing that we were doing initially inside our own applications, our own microservices. And when we adopted KSQL, we were able to offload a lot of that processing onto those KSQL servers, so that in turn, our microservices could then focus on really the core business logic of understanding what that information meant and what do we do with it. And just let the KSQL statements running on the KSQL cluster managed by Confluent handle all of that load, scale up and down in real time, and just keep functioning without a hitch. So here's an example of what you can do with KSQL. So one of the components of the flight state engine is this management interface. It's this user interface, which is here. It's this thing, the FSE management UI, and it's a tool that a few very specialized people in Virgin use to monitor the flow of events coming through the flight state engine. So they're not operational in the sense of they're not running catering operations or whatever. They're just looking at this flow of events and making sure that it makes sense. And this is what their view of the world looks like. And we use KSQL to allow them to query for the series of events that represent the state or the evolution of the state of a particular flight over time. And then you can drill down into any one of those events and look at the fine-grained detail of what that event looked like, and what was its original source, and what was the content of the event in its original language, and then what did it look like once it got translated through to our common language, et cetera. And we do all that with KSQL. So that's a perfect example of using KSQL as a way of managing Kafka topics as data sources. One of the questions that we got a lot at the beginning at Virgin is, this is all very well, but where is your database? Where is your relational database, where you're going to store all this information? And our answer is there is no relational database. It's all done off of Kafka topics. It's all done in this case in KSQL.